Today's lesson is reasoning in algebra and geometry. Take a minute to read the learning goal and find where you are on the scale before the lesson. Algebraic properties of equality are used in geometry. They will help you solve problems and justify each step you take. In geometry, we accept postulates and properties as true. Some of the properties that we accept as true are the properties of equality from algebra. The addition property of equality is if I add the same number to both sides of an equation, it will result in an equivalent equation. So if I start with a equals b, and I add m to this side, I must also add m to this side, keeping a plus m equal to b plus m. The subtraction property of equality states that subtracting the same number from both sides of an equation will also result in an equivalent equation. So here, if a equals b, then a minus m will equal b minus m. The multiplication property of equality states that multiplying both sides of an equation by the same non-zero number results in an equivalent equation. So here, if a equals b, then a times m will equal b times m. The division property of equality states that dividing both sides of an equation by the same non-zero number results in an equivalent equation. So here, if a equals b, then a divided by m will equal b divided by m for any m that does not equal 0. The reflexive property of equality states that a number is equal to itself, x equals x. Think of looking in the mirror. You see your reflection. You see yourself. The reflexive property of congruence states that a figure is congruent to itself, so angle A is congruent to angle A. The symmetric property of equality states that the sides of an equation can be switched. So if A equals B, then B equals A. Think of something that is symmetric is the same on either side, so it doesn't matter which order you put them in. The symmetric property of congruence states that the sides of a congruent statement can be switched. So if angle A is congruent to angle B, then angle B is congruent to angle A. The transitive property of equality is pretty cool. It states if two numbers are equal to the same number, then they are equal to each other. So if A equals B and B equals C, then A equals C. The same is true for the transitive property of congruence. Here, if two figures are congruent to the same figure, then they are congruent to each other. So if angle A is congruent to angle B and angle B is congruent to angle C, then angle A is congruent to angle C. We'll use this a lot in some of our proofs. Let's take a look at each equation or congruence statement and determine which property is used to get from column 1 to column 2. In the first example, here we have 6n plus 9 equals 15. Then, if you notice, we subtract 9 from both sides. Since we're subtracting to get 6n equals 6, we would be using the subtraction property of equality. In the second example, it says segment JK is congruent to segment GH. In this column, however, the two segments have been switched, so segment GH is congruent to segment JK. If they're the same on either side, we're using the symmetric property of congruence. In the third example, angle QRS is congruent to angle UVW, and angle UVW is congruent to angle XYZ. Since both of these angles are congruent to the same angle, they are congruent to each other. Angle QRS is congruent to angle XYZ, so we are using the transitive property of congruence. In example 4, the measure of angle 4 equals the measure of angle 9. Over here, we have added the measure of angle 1 to the measure of angle 4, and the measure of angle 1 to the measure of angle 9. So we have used the addition property of equality. If you're not sure whether you're using the property of equality or a property of congruence, check out the sign between each side of the equation or statement. If it's an equal sign, it's a property of equality. If it's a congruent sign, it's a property of congruence. For 5 and 6, we want to write a new congruency statement using the transitive property. So for 5, angle DEF is congruent to angle ABC and angle JKL is congruent to angle DEF. Since both angle ABC and angle JKL are congruent to angle DEF, these two angles are congruent to each other. So we will write angle ABC is congruent to angle JKL. Number 6, segment RS is congruent to segment VW, and segment RS is congruent to segment XY. Since segment VW and segment XY are both congruent to segment RS, these two are congruent to each other. So segment VW is congruent to segment XY. Don't you just feel super smart? The substitution property of equality states that if two numbers are equal, one number can replace the other in an equation. The same is true with the substitution property of congruence. If two figures are congruent, one can replace the other in a congruency statement. In example 1, if the measure of angle G equals the measure of angle H, and we also know that the measure of angle G plus the measure of angle A equals the measure of angle B, we can rewrite the statement replacing the measure of angle G with its equivalent angle H, and write the measure of angle H plus the measure of angle A equals the measure of angle B. In example 2, if segment TV is congruent to segment WX, and we also know that segment WX is congruent to segment YU, we can replace segment WX with its congruent figure, segment TV, and rewrite the statement as segment TV is congruent to segment YU. Most of us are familiar with the distributive property and how we can use multiplication to distribute a value to each term of a sum or a difference that's in parentheses. So here we're taking A and distributing it to B and to C, giving us A times B plus A times C. Over here we're taking A and we're distributing it to B and to C, giving us A times B minus A times C. We use deductive reasoning when we solve equations. We can justify each step with a postulate, a property, or a definition. For example, we can use the distributive property to justify combining like terms. If you think of the distributive property as A times B plus A times C equals A times B plus C, or A times B plus A times C equaling B plus C times A, then 2x plus x would also equal 2 plus 1 times x, or 3x. In example 1, we want to find the value of x and justify each step as we solve. We can see that angle AOM and angle MOC are supplementary because they are a linear pair. So the measure of angle AOM plus the measure of angle MOC will equal 180 degrees by the definition of supplementary. Let's substitute 2x plus 30 in for the measure of angle AOM and x for the measure of angle MOC. So 2x plus 30 plus x will equal 180. Next we can use the distributive property to combine like terms. Let's use the subtraction property of equality to subtract 30 from both sides. And finally, we'll use the division property of equality and divide both sides by 3. So these are the reasons why x equals 50. Pause the video and do you try number 1. It is given that ray AB bisects angle RAN. Therefore, we know that x will equal 2x minus 75 by the definition of angle bisectors. Let's use the subtraction property of equality to subtract 2x from both sides. And finally, let's use the division property of equality to divide each side by -1. So these are the reasons why x equals 75. Pause the video and use the properties of equality and congruence from the beginning to do you try number 2. Now check your answers. A proof is a convincing argument that uses deductive reasoning. A proof logically shows why a conjecture is true. A two-column proof lists each statement on the left. The justification or reason for each statement is on the right. Each statement must follow logically from the statement before it. The diagram below shows the setup for a two-column proof. We will be completing a lot of proofs this year. In example 3, we are given that the measure of angle 1 equals the measure of angle 3. We are asked to prove that the measure of angle AEC is equal to the measure of angle DEB. We'll start with the measure of angle 1 equaling the measure of angle 3 as the given. For step 2, we'll state that the measure of angle BEC is equal to itself, the measure of angle BEC. This is the reflexive property of equality. Next, we'll take our first statement and add the measure of angle 2 to both sides. The measure of angle 1 plus the measure of angle 2 will equal the measure of angle 3 plus the measure of angle 2. This is the addition property of equality. Statement 4 is that the measure of angle 1 plus the measure of angle 2 will equal the measure of angle AEC. This is the angle addition postulate. Statement 5 is that the measure of angle 3 plus the measure of angle 2 will equal the measure of angle DEB. This is also the angle addition postulate. Statement 6 is the measure of angle AEC will equal the measure of angle DEB. This is substitution property. Pause the video and do you try number 3. In this two-column proof, we are given that segment AB is congruent to segment CD and asked to prove that segment AC is congruent to segment BD. Let's start with our given segment AB is congruent to segment CD. Next, we'll write that the length of segment AB is equal to the length of segment CD. That is because congruent segments have equal lengths. In statement 3, the length of segment BC is equal to the length of segment BC. That is the reflexive property of equality. For statement 4, the length of segment AB plus the length of segment BC will equal the length of segment BC plus the length of segment CD. That is the addition property of equality. In step 5, the length of segment AB plus the length of segment BC equals the length of segment AC. That is the segment addition postulate. For step 6, the length of segment BC plus the length of segment CD equals the length of segment BD. That is also the segment addition postulate. Step 7, the length of segment AC is equal to the length of segment BD. That is substitution. Finally, we can say segment AC is congruent to segment BD because segments of equal length are also congruent. Now's your chance to shine. Pause the video and complete the lesson check. Don't forget to check your answers on the next slide. If you missed any of these, be sure to ask me in class tomorrow. Are you really feeling smart? Go ahead and try the challenge. Reread the learning goal and find where you are on the scale now after we've completed the lesson.